Hello friends, today we'll learn about the random forest regression. So first make today's agenda. Random forest regression. It's a basically decision tree. If we talk about the decision tree, it's based on the classification. Classification is two types. One is the classifier type. It's basically regression. Regression is basically two types. One comes under classification, one comes under prediction. Prediction means when you will going to predict something. That means your salary, your age, etc. Classifier comes under when you classify something. It may be true or false. It may be male or female, etc. Okay. So I'm writing here as well. So it is basically one type of dysentery. Okay, so I'll explain everything in details as soon as the video is start, and I will import all the libraries as well. So first I'm importing all the libraries. Okay, so import numpy as mp, import pandas as pd, import sklearn dot model selection. Not it will be import, it will be from sklearn dot model selection, import trend test split from sklearn dot ensemble. Now I'm going to import the random forest regression. Okay, sklearn basically a library, and ensemble I'm going to write ensemble basically module. Okay, so from sklearn dot ensemble import random forest regression, and I'm importing another thing as well, that is the to check the accuracy, etc. The error at the end of the result. So I'll import from sklearn import matrix. So let's run it. Now I'm importing the data set. Those who are interested for the data set, kindly mail me. I'll share that entire data set. So gold. In this example, I am taking the gold data set. So as per the gold, first I am importing the data set, then I will explain. So gold data pd dot read csv, since it's a csv file, that's why I am writing read underscore csv. Now I am entering the path details where I have kept my file. And let's run it. Now I'm checking the gold data. Okay, this is the gold data. So today in this example, what I'm going to show you that it is the basically gold price. Okay, so it is gold price and the different date. Okay, from 2008 to 2018. So we're going to predict the gold price based on the other parameter. So our output will be the gold price. Okay, so I am splitting the gold data into the two variables, like x variable and y variable. And in x variable, I am taking as input, and y variable I am taking as output. So I'm writing here x, then gold data. Then I'm dropping, that means I am eliminating few columns from the goal data. So I'm eliminating date, that particular column from goal data, as well as the gold, that particular column from the goal data, because so that I can choose gold as a output variable. I will take gold as a different variable, like y variable. I will take it. So comma axis is equal to 1, y axis is equal to 1. We are going to drop the columns, that's why we will put the axis is equal to 1. If we put the axis is equal to 0, in that case it will eliminate row. So let's run it. Let's run it. Here we are observing that only 4 columns are there in X. In Y we are putting gold data. Since we are going to find out the gold price, so we are putting the gold price in Y variable. So let's run it, and you will get the value of Y. That means it is only indicating the gold price. Okay. And apart from gold price, all the columns, and obviously I am eliminating the date column as well. So date and gold, if we exclude these 2 columns, other columns are under the X variable. Okay. So now I am distributing my entire data set into 2 ways. Few of the data set I will take for training purpose. Few of the data set I will take as a testing purpose. Okay. So I'm writing xtrain, xtest, ytrain, ytest, then train test split x comma y, then test size is equal to 0.1. That means I am taking the 10% of my entire data set as a testing set. You can take the 20%, 30% as per your choice, but I am taking the 10% of the entire data set in my testing set. And I am doing the random state is equal to 2. Random state is equal to 2. It signifies that the entire date, you can put the random state 2 or you can put random state 3 as per your choice. But if you select the random state 3, in that case your result will not be similar with my result, because in that case your data will be split in different way if I compare it with the my data set. Okay. So let's run it. Train test. Okay, I am putting class here, so let's rectify it. I can run it. Okay, so I'm just showing you my entire data set once again. X shape, X train shape, X test shape. So let's run it. So it was the total data. It is under X train and it is under X traced. Okay. Now I am taking one variable as a RF. Okay, RF basically I am putting the random forest regression. So let's run it. Now RF dot feed. Now I am going to fit my training data set. Based on that training, I'll predict the test. So first I am fitting into the model my training data set. So I'm writing X train and Y train. So let's run it. Okay, X train. Okay, I have made the spelling mistake here. Let's run it. Okay. Now I will predict the accuracy based on training. I will explain later why I am finding the accuracy based on training, and the later stage also I'll find out the accuracy based on testing. So that means I want to say that I am finding accuracy based on training as well as testing. Why I am doing so, I will explain it later. Okay. So I am predict. So let's write it in this way, that predict training is equal to rf dot predict. Now I am writing X train. That means based on the X train data, I am predict something, and I know that the Y train is the true value. So later stage, I will calculate the error difference, the prediction and the true value. True value means Y train. Okay. So let's run it. Now I am going to find out the error score. Error based on training. Okay. So I will use matrix, then R2 score, then I will put the true value, that means the Y train, it was true value, comma, predict training. This is the value which we have predicted. So let's run it and let's print it, this value. So it was 99. It was not accuracy score. So we can say the model is good if I compare with the training. So do the same thing, but in this case, I will do based on test. So let's copy it and let's paste it. And again, let's copy it and let's paste it. But here I will write test. And here also I will write test. Here also I will write test. And here also I will write test. And here also I will write test. That means the error based on test. So let's run it. Now let's print it. Error based on test. It was the 0.98. So error based on training, it was 0.99, and error based on test, it is 0.98. So we are observing that both the results are similar. So we can say that the data are not overfitting or data are not underfitting. If there is a difference between the result which you are getting from training and which you are getting from testing, if there is a difference, okay, so we can say that there must be a issue. Issue is issue in the sense that might be data is overfitting or underfitting. If the training result is good but testing result is low, training result is good means I want to say that the training result is high. but testing result is low, in that case, we'll say that the data overfitted. And if the opposite scenario comes, that means the training data error based on the training is less and error based on the testing is more. Okay, so in that case, we will say that issue is in like the underfitting. Okay, and one more thing, it is not any type of accuracy. So we can't say that the system is 99% accurate or system is 98% accurate. We are just getting the root mean square, R2 score, that means the root square error we are getting. It basically depends on the number of values and what type of values you are using. So it is not based on the accuracy. Okay, so we can't say that the accuracy is 99% or 98%, but it is quite good because the amount of data and the, if we see that the values of data we are handling like 84, 124, 122 in this range. So if we consider these ranges of data, that means the gold value, these ranges of data, in that respect, this value is quite good. That means our model is good. This was all about for today's video. Thank you.